If you are running a Shopify store, then there is a high chance that you have already shipped orders to the fraudsters. But you didn't even realize it because fraud in e-commerce doesn't shows up immediately. It shows up later at chargebacks. Till then, your product has bought, your money has gone, and you are paying extra fees. Let me ask you something. Do you ship orders without verifying your customer details? Do you only check high value orders manually? Have you received any chargebacks before? If answer to any of this question is yes, then your store is exposed. Because the problem is fraud doesn't look obvious. One bad order doesn't hurt, but over the time it quietly adds up. Even 5 to 10 orders per month is going to easily cost you $10,000 to $30,000 every month. So instead of guessing which order is risky, we built a system which is going to analyze every order before it's shipped. And let me simplify how it works. So every order is going through this risk engine, and instead of relying on our gut feeling, we will be dependent on these three factors: order risk, customer risk, and network risk. So in the order race, what it is going to do? So order race is going to be consisted of three things. In that, we will be checking three things. Like if the billing address and shipping address is not matching, then we can consider that factor as a risky factor. Similarly, we can mark some countries as high risk countries, and if any order has been triggered from those countries, then we can give some score. Means we can consider that in the order race. If any order has large quantity, then we can consider that as a risk. So these three factor contributes to the order risk. Then in the customer risk, we are considering the four factors. So in the customer, for that we will be checking the customer history. In that customer history, if the customer has high refund rate or not, if he have previous chargebacks, if this is a first time customer, and if he is ordering high value products. Then we are also checking if this is a order spike. Like till now he is ordering 1 2 products, and now suddenly he started buying multiple products, too much products. Then these factors will be considered as customer risk. And lastly, we will be considering the network risk. So in the network risk, we are considering these three factors. If same IP address from the same IP address, multiple orders has been triggered. At that time, we can consider that as our network risk. Then also we will be checking high activity. Like in 1 hour or 24 hours, we will give some threshold number of orders, and in that means if the order have crossed that threshold number, then we will consider that as a high activity order. So we will be also considering this as a risky factor. And suppose from a same location with different username, different customers are buying the products, so it is also considered as a risky factor. So these three factors are contributing to the network risk, and these three factors, like these three risks, order risk, customer risk, and network risk, are going to calculate the total risk. So we have calculated the weighted risk score. So we will be using this risk score and assigning it to the some levels. So for to calculate these levels, we are using few checks. Suppose if the total risk score is greater than 60, then we will say that this order is high, means this order is risky, very risky. Then we can say that hold this order for the fulfillment. If the score is between 60 to 30, then we will consider that as to be reviewed. And if the order score is less than 30, then we will simply approve that orders. So this is how our fraud detection is going to work in theoretically. So now I will show you the system in action. Log on to our Shopify store, then continue the shopping. Let's do one thing. Let's buy some products first. So I'm buying some glasses here. So I'm adding multiple products. So the quantity is 11. I have adding it to cart. So now let's do one thing, buy now. When we click on the buy now, so here let's add some dummy email address, dummy123@gmail.com. So delivery address is going to be the United States. So the name is going to be Jackson and last name is going to be Jin. So in the address, let's add some dummy address here. So I'm just adding some dummy address. Then let's add the payment details. So now we will be using the shipping address different from the billing address. So the billing address is going to be, so what I'm doing, I am doing the billing address from the country Bangladesh. So what I have done, so if you can see on this diagram, we have multiple factors while calculating the risk. So for this case, when I am demonstrating this, so we have considered as billing address is not equal to shipping address. So we are making one order considering the billing address is not equal to shipping address. Then we are also considering the billing address is from the high risk countries. Then we are also considering it is a large quantity. So these three parameters are fulfilled by our this previous order. Then we are also considering the network risk factor. So what I have done, I am buying this product, means I am doing the shopping from the my Revix that Revix store from this day. So means I have buy multiple means I have tried multiple orders. So this case, the multiple customers from the same IP. So this will be fulfilled. Then high activity is also going to be fulfilled. So now let's check what happens. So let me just add this information here. User one, last name, last name. So let's add the address here. 123 Lynn. Then our city as Nagpur. So now I'm in the pay now. So when this order has been triggered, so what it is doing, so we can see that on the screen, the order confirmation screen, it has popped to us. So now let's go on to the Shopify store. Order has been triggered at 434 for this one EP. So what it has done, it has marked that order as on hold because it is a high risk order. So because of that, we have marked this order as a on hold. So let's click on this order to see this in details. Why and what issues has this order and why this mark as a high risk of fraud. So in the fraud alert, this is the fraud alert. Then the risk score is 56. Total risk is 56. Then the risk confidence is moderate. Risk level is medium. And reason of marking this as the risky is billing address and shipping address does not match. Then the large quantity spike. Then high value first order. Then high IP velocity in 1 hour. Also high IP velocity in 24 hours. So this is how this order is on the on hold. So this is how it is going to work. So from that we can, from this screen only, we can release the hold also. So yeah, this is how it is going to be. So let me show you how this is implemented. So for the implementation of this automation, we have used the NetApp. In the NetApp, let me show you this in action. So now let me explain you how this system is implemented. So to implement the system, we have used the NetApp. So let me walk you through how this system is working. So firstly, we have created one webhook. In the webhook, this URL we have created and we have pasted this, means we have registered this webhook URL with our Shopify store. In the previous video, you can watch here. We have already, I have already shown you that how to register the webhook URL into the Shopify store. Then we have created 3 tables. Means we have created one database to store the customer order and IP related information. Means like we have designed our system like if it should learn and it should use the previous data to calculate the frauds. So for that, we have created these 3 tables in the database. Order is logs, customer is profile, and IP order events. So in the order is log, we have stored all the order related information like order ID, order date, customer ID, customer email, order value, currency, shipping country, billing country, IP address, and AVS results and CVV results. So we have considered these 2 columns for the advanced fraud detection tutorial. So we will be talking later about them. Then another table is customer risk profile. In the customer risk profile, we have stored all the related information to the customer. So in that you can see that customer ID, email, and the total orders, how many orders that particular customers have registered with us, then the total refunds, how many refunds that particular user have, then the refund rate, then the total chargebacks, then the average order value, last order value, then the risk trend, then the lifetime risk score. So we have means we have stored this all the information so that we can calculate the proper risk score for that customer. Then lastly, we have the IP order event. So in this table, we are storing all the orders related information like the order has been triggered from which IP address and for which customer ID. So this is the table. In that we have IP address, order ID, order timestamp, customer ID, and the order line. So we will be using this three tables data to calculate the risk score. So firstly, what we have done, we have fetch all the information from these tables. From the firstly, we have to calculate the customer risk profile. We have check for that customers. So this one is a new customer. So for this customer ID, there was no order present. So this was its first time. So because of that, his information is not present in our customer risk profile. So because of that, it has returned as the empty. So now we are calculating the customer risk. To calculate the customer risk, what we have done, we have taken the all the data into some variables. These variables we have created total orders, then the total refund rate, chargeback, average order value, and store it into these variables. Then we have taken the current order value. So we will be using this for the our users. Then we have created two variables. One is the customer risk. So here in this variable, we are calculating the customer risk. In the reasons, we are adding all the reasons. So here, if you can see, to calculate the refund rate, to customer related risk, we have considered the multiple factors as I've shown you on the diagram. So here is the first one. So we are also checking the refund rate. If the refund rate of that customer for that customer is greater than 60, then it's a risky. So that's why we are adding the 40 points to the customer risk. Then we are also pushing the reason. Similarly, if the refund rate is greater than 40, then in that case, what we are doing, we are just putting the 25 points into the customer risk and also putting the pushing the reason why this is a risk. So we have added this. Then the chargeback. So suppose if the customer have done the chargeback, then it is a very risky order. So because of that, we are adding 50 points to the customer risk and also adding the reason for it. Then if the this order is a first time order and it's a high wage order, so we are considering that factor also. So here we are calculating that and we are adding the 30 points for that. Then if the average order value was 0, means greater than 0, and the current order. So now previously till now, if some old customer has some orders, so from his behavior, he's have some X amount of or average order value, and suddenly he have bought more than 2x of his average order, then we can say that it's an unusual order value spike, and we are adding the 20 counts to it. And lastly, we are just returning the result. So for this our order which I have shown to you. So for that, the risk customer risk was 30, and the reason is high value first order. So this is how the customer risk was calculated. Let's check the IP related risk. So in the IP related risk, we from the same IP, I have bought 5 I have triggered the order 5 times. So because of that, it has given us the multiple data. So let me show you. Sorry, 9 times. From the same IP, 9 times the order has been triggered in last few days. So what we are doing here, we are calculating the score based on the last 24 hours and last 1 hour. Yes, yeah. So here we have taken the 1 hour ago timing and 24 hours ago timing. Then here we are checking the items. If you have any items in the from the IP orders tables, then we are iterating over it. Then we are taking its timestamp, and if the timestamp is not equal to null, then we are taking the event time. Event time is greater than or equal to 1 hour ago. Then we are considering it as a orders last hour. Then this event time is greater than or equals to 24 hours above timing, then we are considering this as a order last 24 hours. Sorry. So this is how we are calculating the number of orders in the last 1 hour and last 24 hours. Then also we are checking if the unique customers from the same IP. So here in the unique customers variable, we are adding the customer IDs. So we can also see, this will cover the case of the multiple orders from same IP with different customers. If the last on orders are greater than or equal to 3, then we are adding 30 points to the network risk and adding the reason for it. And if the order last 24 hours is greater than or equal to 5, then it's we are adding the 40 points to it. And similarly, we are adding the reasoning to it. And we are also doing the one thing, that is a multiple customer from same IP. So for that, we are adding the 40 points. So this is how this JSON is created, and we are executing this. So for this order, the network race was 1110 and IP states. So in the order last hour, there were 8 orders, and in the last 24 hours, there were 9 orders, and unique customers was 3. So from the same IP address, 3 customers have buy, and this was the number of orders from the last 24 and last 1 hour. And reasons are the high IP velocity in 1 hour, high IP activity in 24 hours, and multiple customers from the same IP. So this is how this IP related risk information has been calculated. Similarly, we have calculated the order related. So here in order, to check the order, so I have already told you that we are considering the billing and shipment mismatch. Then we are also considering the high risk countries. Then we are also checking the quantity spike. Yeah, one more thing. So this high risk countries, just this is for the just demonstration purpose. I am not. I don't know if it is a high risk countries or not. I have just added it. So based on this calculation, we got the order risk as 65, and the billing order reasons are billing, our shipping, country mismatch, large quantity spike. So we are gathering this all the data in the merge cell. Then we are calculating the risk. To calculate the risk, I have already shown you at how we are calculating the risk. To calculate the risk, we are using that formula, that is the order risk into 0.4, customer risk into 0.3, network risk into 0.3. So this is how the weighted scoring is created, and we are calculating the total risk. And we are also passing the reasons, risk confidence, risk level, total risk, and the breakdown. So 68 was the point of the total risk, and the risk level was high. So here we have calculated the risk. So now we have added one switch mode. So based on that, if the risk level is high, medium, or low, based on that, we are taking some different actions. So here we have added some tags here. For the high risk, we are adding the high risk tag. For the review tag, for the review, we are adding the review tag. For the verifier, we are adding the verified tag. In this added fields, what we are doing, we are calculating, we are considering these all the tags and created one variable, and in that variable we have added that tag. Then in the next step, we are creating one API token so that we can make the request to our Shopify store. For that, I have already explained you how to generate the API token. So you can watch this previous video to get this API token and how we have created this API token. So this API token we have created. So here is the URL. Then we have added the grant type as the client credentials, client ID, client secret, and it has given us the API token. This is the access token for my store. Then here we have added one condition. This condition states that if the risk level is high or medium, in that case we have to hold that order. So for that, to hold that order, first we need to get the fulfillment details, because we need to stop the fulfillment. So what we are doing, we are making one request to this API. So let me show you this API. So here this API, we have added this API, and we are making the request to this API. For that, we need to pass the access token, which we have created in the previous nodes. So we are adding that access token in the header authentication. So let me show you how we have added it. So here in the, I have created one authentication video. So in the name of the header authentication account, we have added some name to it. Then also we have added the API token to it. And with this, we have added the headers as content type and application/JSON. So it is giving us the fulfillment details of that particular order. So this is the fulfillment details, and we will be using this fulfillment ID number to stop this fulfillment in the next node. So here is the whole shipment. Here we are making the request to this GraphQL URL. So in that, what we have done, we have used this URL. Then we have also specified headers in that. So content type is application/JSON. In the JSON body, we have created this parameter to make the request to the graph. So here is the query. In that query, we have to do this notation fulfillment order hold. Then we have to pass the ID, the reasons, release notes. So for the variables, we have created this query. In that query, we need these variables. So these variables are ID, reason, nodes. So we have added these details here. And lastly, when it runs, it will mark that shipment as whole. And lastly, what we are doing, we are just we are adding the tags to that particular order. So this one is the tags. So this one is the order, this order ID. For this order ID, we are updating the tags. Then we are also adding the nodes to it. And the request which we have used, this one is the request. It's order/order ID.json. Then similar header authentication. And if any new order is there, or means after updation of our orders, means after doing this all the things, we need to update these tables. So in the create order list logs, we are adding this order related information into that DB. So this is the data which we are sharing with this DB. So this will store that data into the DB. Similarly, we are also adding the IP related data. So this is how we have added the IP data. Then here we are calculating some risk levels. So we need to add the last order value, then the lifetime risk code, then risk trend, average order value. So these all the things we need to calculate. To calculate these things, here we have used one code node, and here we have calculated all the things. So firstly, we have extracted data into these variables: total orders, total refunds, chargebacks, average order value, previous lifetime risk. Then we have also extracted the current order values: current order value, current total risk. Then in the new total, so previous total plus 1 is going to be the new total for the orders, then new average order value. So we have first added the current order value into that, and to calculate the new average order value, we are just use the average formula and calculating the new average order value. Similarly, we are calculating the previous lifetime score based on the weighted scoring method. So for the previous lifetime score, we have given the 70% weightage, and current total risk score, we have given the 30% weightage. And we are also considering the risk trend. So if it is a stable, increasing or decreasing. So for that, we have checked the previous lifetime risk. If it is greater than 0, then we are checking the current total risk is greater than previous lifetime risk into one quantity. So we have done this weighted. So we have given this number, and based on this, we have calculated the risk trend. So if previous lifetime risk was greater than 0, then based on that, we are calculating if it is decreasing or increasing. Then next, we are calculating the refund rate. To calculate the refund rates, we are just using one of our formula to calculate the percentage. Total refunds divided by new total orders into 100. So this is how the refund rate is calculated. And lastly, we are we are getting the final clean output. So this is the final clean output, and we are just simply checking. First, we are checking if the customer information is present on that DB or not, on that table or not. If it is present, then we are updating that record instead of creating a new one. So here we have updated that record, and if it was not present, then we are creating one record. So this is how this system is created. Can save anywhere between $10,000 to $25,000 per year, not just from frauds, but also from the reducing manual work. And the best part is it runs automatically in the background. If you run a Shopify store and want something like to be implemented, then you can check the description or reach out to us. I will be sharing more systems like this, from fraud detection to customer intelligence to backend automation. So if you are building e-commerce brand, then consider subscribing us. Thank you.